So thank you for coming to the first joint meetup between PyData and Python Milan. Python Milan is the local community of open source developers in Python, and PyData is a non-profit funded by NonFocus to promote open source science, specifically with Python and data science and artificial intelligence. We are very dedicated to promoting the values of inclusivity because our focus is community. So please be nice to people. And we target monthly meetups on the third Wednesday of the month. And as I said, we are focused on building a community. So we take proposals for new talks. So if you have an interesting presentation for us, please be in touch. And we also like to have dinner after our events. So if I can also take one moment to take a head count of how many people will join us for dinner after the talk. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Ok, fai 15 se si aggiunge qualcuno. Ok, so these are gonna be our next dates, so check out the meetup and please remember to register. We wish to thank our host. We work in partnership with many companies around Milan. Today our host is TrueLayer, so if you can give a little applause. And we also want to thank Python Italia and Division Lab for giving us the video equipment and supporting our lives on YouTube. So I don't want to steal too much time. I leave the floor to our first speaker, Domenico Nucera, for practical Python parsing. The floor is yours.
Can you hear me? Is the microphone working and everything? Yeah, okay, it's working. So just give me 1 second so that I can share the slides. Okay. Allow everything. Okay. Okay. I would like to talk to you about the AST library. Python has a standard AST module. Just as a curiosity, how many of us actually know the AST module from Python? Okay, some of us. How many of us have actually ever used it? Tried to do some crazy stuff with that? Yeah, okay, we have some, okay. Few, but we have some crazy people who actually did stuff with that. Okay. Well, the AST is basically a standard module in Python, and basically it gives you the abstract syntax tree that is one of the results of the various steps of parsing. So basically there is tokenization, parsing, and at a certain point you obtain an abstract syntax tree. Python needs an abstract syntax tree to work so that it can basically just take the stuff, generate some bytecode. But basically, the AST exposes all of these internal functionalities to you, so that at any point you can basically just, we will see, take your Python code and obtain and play with your own abstract syntax tree and do, well, not much, I'm not going to do crazy stuff, but I hope stuff that basically turned out to be useful to me. A little bit of backstory. I discovered the library 2 years ago, in 2023, at PyCon Italia in Florence. During a lunch break, I needed it for a personal project of mine, and a super guru told me, yeah, you should just try AST. AST was super good, super cool for the stuff that I needed to do. And then at a certain point, well, it started to help me at work, so sometimes I use it, and I have to say that it is quite useful. So a little bit of the agenda, I would like to say some why, so motivating why AST can be useful, Then talking about the tree, the abstract syntax tree, its nodes, I think they are pretty important. Then how to traverse our tree, how to walk, and hopefully, if I make it in time, just to show some code, just try to write all together some code to actually play with the library and do some fancy stuff. So, use case. We have to process some Python code. Like, we are all like developers, data scientists. We connect with DBs, we open CSVs, Parquet, whatever. At a certain point, you can say, let's say your situation is the raw data that you have at hand is your own Python code for whatever reason. It could happen sometimes. And what can you do? Regular expressions. I see some loves and jokes. They are good. Like, actually, you can do you can do a lot of stuff with regular expressions, and they are really a good idea. Or if you are like some kind of like very maybe young, not expert and crazy person, you can start to write your own stuff. Like let's split in the lines, let's remove the tabs if this thing is in the string, and yeah, we do this kind of stuff. It works. Or nowadays you can even take your code and give it an input to an LLM and ask him some prompts. The LLM is going to give you stuff, and all of these things, they are actually good, they are useful. They just, however, have some kind of limitation. Actually, you are managing a string, so you are still in a string manipulation phase. It's as if you were to open a CSV and, okay, you are just open it as a string. No, we never open CSVs. We just import data frame, and data frame does everything for us. So it could be useful if you need to handle your own Python code to leverage the formalism inherent in the Python code and actually use a higher level of abstraction, which basically is AST. Just import AST, parse it, and you will have a data structure. You will not have a string anymore. You will just play with this data structure, which will represent your own code. And that's what I'm going to talk about. One last great motivation to super motivate us is very cool people that do very cool stuff with AST. Just to give you an example, PsychoPG3 is like a module in Python with which you can connect to Postgres databases. The author of the library basically published this blog post in which he describes how he basically writes the asynchronous code for PsychoPG3, and then he doesn't write the synchronous code. He wrote a snippet in Python using AST. It's basically a variant of AST, but basically something that heavily relies on abstract syntax trees to write the synchronous code. He doesn't write the synchronous code. That's just something that the machine does for him in a very deterministic type of way. So at this point, maybe you are curious, how do we obtain this phantomatic AST? It's super easy. AST is in the standard, so just import it. It has a function called parse. You can feed it in input a string. You will obtain the abstract syntax tree, and you're done. From now on, you can play. And just in this example, I then use a function dump. I pass to it a tree. Dump is like JSON dumps, just it will return me a string with, how to say, the module in some way just printed and represented. And as you can see, basically, we gave it a print hello world, and this thing returns to us a module. Parse assumes that this is a whole module with a body, which is a list of expressions, one expression, a call to a function with a name, which is print, to which we are passing a constant, because actually this thing for him, it is a constant. It is hardwired in the code, this hello world. So this thing basically tells us that we have a program which is a function call, which is print, and we pass to it a string called hello world. And something that you can be like, okay, thinking about it, like if this is like your first impact with an AST as I had like 2 years ago, you can think, okay, there are nodes which are of different types. And basically, the idea when you play with an AST is that, of how the library is structured, is that for every Python grammatical expression, you will have a corresponding AST node type. You will have a corresponding class in your AST. And well, polymorphic is not the right word to describe it, but I hope it gives you the idea. If you like the first tree that could come to your mind, it's the binary tree maybe, like, okay, every node is the same, it has a left child, it has a right child, and all the elements, all the nodes are of the same type. They can be seen as classes all of the same type. Forget it if you're playing with an abstract syntax tree. No, every node will be different. As we saw, we have a module, then there are assigned statements. Functions, they are functions definition. They have their own body, but then they also have their own name, their returns. Like, get ready for nodes of many different types. So that's kind of a thing to which that I think is pretty important if someone needs to basically just roll around and play with the library. If one goes and checks the official documentation, one can see there are like plenty of different nodes. Don't be afraid, they mostly make sense. I would like to highlight some of the ones that are actually, like, how to say, counterintuitive, but those are, well, those are the abstract syntax tree. There are some things in common that you can basically just try to leverage, maybe not always, but most of the time. Some nodes, they give you like their coordinates inside the code. So nodes will have a line number and line number, their column offset, and basically, okay, they allow you to say, okay, this node was positioned in this part of the code. And then most of the stuff that basically, like, how to say, they involve using a tab. They involve some substatements like functions, loops, fors, ifs, try statements. They all have a body. They all have this attribute, which is a list that you will refine several and several times. That is a list of its own substatements, as we will basically see. Which is basically this. You can say, okay, I have whatever function, put some assignments, and then say, okay, for e in the range of this function, just do this kind of stuff. This is a body with assignment, for, return, and the for is going to have itself a body with its own children, which then are some assignments. The whole point about managing the abstract syntax tree is that you will see that nodes, they have their children, which are expressed in different ways. Sometimes they are directly an element. Sometimes you will see, okay, this node has a value. Sometimes there will be a situation, okay, in which this node has a body, several different types of body, which are actually lists of nodes. But in general, what you will see is that you have either like direct connection to children or attributes that are lists of the children of a specific body. And I believe it is worth it to just go through some example of nodes. And they are going to be useful the moment that we are going to basically play with visitors and transformers at a certain point. So they are mostly boring, they're mostly intuitive, but they will turn out to be useful, especially if we get to the demo. So just obvious stuff. You define a class, this is a class def. You have a function, this is a function def. An example, a return statement. This is a node. This is an element of the syntax in Python, of its grammar, and then this is a node. You're calling a function. This is, please forgive me for the two dots. They do not belong there. But this is a call. Data structures, they have their own nodes. So, for example, if you define a list, you will have your own node as a list. You can have a node for a dictionary. You can also have nodes for the comprehensions and so on. And all of these things, they mostly make sense. But there are some subtleties, and I would like to warn you, because I would like to tell this thing to somebody, because nobody told it to me 2 years ago. And some things, they are kind of like, okay, you can guess them. Maybe if you're interested in checking like your own imports, just forget about import lib. But if you're interested in checking your own imports, you will see that there are two different grammar types, different grammar ways in Python to do it. Okay, those are two different nodes. So when we are interested in say, okay, what are all the imports of a file, you just need to track two different nodes. Something a little bit more subtle. Function definitions. If you say that a function is asynchronous, this is a completely different node. So if you are thinking, okay, let's take a look in my code that all the functions that I have, you defined wasn't as async, okay, you need to take a look at a different type of node. Because if you tell something like, just take a look at all the function def, bang, you're going to miss one if you have an asynchronous one. And the thing that kind of like destroyed my life for I don't know how much longer, those are assignments. So you may think, okay, in this case, I'm taking a variable foo, and I'm saying its value is going to be equal to 1. So those are assignments. No, it's a trap, of course. I give you like it's a trap. this is an annotated assignment. So this is a completely different type of node for Python. So in case you are interested in tracking down, okay, how many times am I modifying this variable through direct assignments, and you just specify its type, something that I love doing, okay, this is a completely different thing. And it also makes sense in the way that the node is structured, because you can play and say something like foo equal to bar equal to 1, and this node has a targets attribute, which is basically a list of the nodes. Grammatically in Python, maybe you don't do it too much, but you can do it. You can assign multiple variables to the same value. That thing is represented by the node. You cannot do this thing if you use an annotation, and you discover this by basically just discovering that annotated assignment exists. And something that I never played with, but I discovered recently just by taking a look at the documentation, try statements. There is a try star. What does it represent? I tried to take a look at Stack Overflow, and they basically said that since Python 3.11, there is going to be exact group, and that basically triggers an AST try star. So if you're going to take a look at your own try statements, just, I warn you, I never played with it, but be careful. There is, there is a try star. Since we were talking, however, previously of type annotations, they are there in the AST. In your abstract syntax tree, you are able to find your own type annotations. The abstract syntax tree treats them the same way that Python does with your type annotation. It does nothing with them, up to my knowledge, it does nothing with them, but they are there. So you can basically inspect them, and you are free to manage them, do stuff with them. Just an example, if you see an AST function def, it has a returns attribute. The returns attribute is basically the value of which the function is going to return. So, arrived at this point, I hope that I described some kind of like, in a very boring way, I suppose, how the abstract syntax tree is done, what it is. Just, I mean, at this point, we can say that we have this wonderful and great data structure of polyforming, variable shape. It's a weird monster that represents our Python code, and we can play with that. Next thing that you may be interested in is, okay, but how do we traverse our tree? And a very cool thing about the AST library that you have at hand, it has a lot of support functionalities with which it already comes equipped with stuff to traverse your tree. You just need to tell him ast.walk. ast.walk is the traverse, it's the way to traverse the tree. You invoke it, you pass it in input the tree, and you are basically going to receive all the nodes unrolled one at a time. It just has a thing. It does so in no particular order. I would like to explain you what it is, how to say you can expect it, may not expect it. I did not expect this, but this is basically how it works. And to showcase it, I tried to make a little game that I'm going to play with, which is basically just a snippet that allows us to check, how to say, a code section, how it is explored, how it is seen from the walk. So basically, this is just some code that I will have that basically is the code that's going to run. We just have some code base just so that you see some AST working. We have ast.parse, we're just parsing the code. We just have some code lines, and then we're just taking all the nodes that come out of walk, if they are printable, if they have an attribute which is line number. I guess that some of you are not able to see, because this is, yeah, I'm sorry, just let's hope that the command works. Oh, okay, so this works. Aside from a lot of crappy boilerplate code that I wrote, nodes is basically a list, so it's ordered, the order and way in which the unordered stuff comes out of walk. I hope that you can see it now, maybe still not. But the interesting part about all of this is the weird game that I prepared for all of this purpose, which is basically like we have, I don't know if I can place it like any way higher. Unfortunately, no, I can't. Can you all see it? Can you all see this? Okay. Just a little bit bigger. Oh yeah, a little bit bigger. Okay. This snippet is going to basically take all the nodes that are in the list, walk them one at a time. It showcases the number of the node, the line number where it happens, and the class of the node. It skipped the first node, which is the AST module. And then we can see that, okay, the first node that came out of walk that was printable is a function definition. The whole code is given by this code section. And if we ask it for like the second node, it will be the if in which you're just saying if name uguale main. This code is just a stupid Fibonacci that I implemented. I hope it works, but I checked it works. And what walk does under the hood, if you go out there and take a look, it starts from the shallowest nodes and slowly, slowly, slowly it descends into the deepest ones. It's super cool. It does a lot of stuff. It will catch everything. but basically it is unordered. So if your hope was, let's say, okay, I'm interested in, at a certain point, reading the function in this way, no, you will not be able to do it. You will just need to go to the second node, and the second node that you will find is actually the children of this function, because then you are going to take the direct children of the function and of the if. In this case, the if, the first if nested inside the function definition. And we can play with this, we can go on and forward, but I would just like to showcase you something, like it catches also like stuff that are not lines, intermediate nodes that are like hidden inside your code. So the super cool thing about walk is that at a certain point, let's say that you are interested in tracking down how many times you are calling a function, and the function is called inside a list comprehension, which is hidden inside some like old bloatware code that you write in a single line, those huge super long one-liners. AST walk is going to catch this. So if you're interested in this, you will find this. And for example, this is a Boolean operation. I hope that all of these node names are kind of like intuitive. I kind of like was able to get like an intuition, and I don't know all of them. Just before the talk, I kind of like read some of them just to remind me, but just kind of like go by instinct. I hope that they are intuitive. We have a Boolean operation highlighted in blue. I hope that all of you like can see the blue color. I was not like not a great developer, so I hope that this is seeable. But this is basically highlighting this piece, and this is a Boolean operation, which is an OR, and we'll have a left and a right, which are an I = 0 and I = 1. At this point, our question may be, when are we going to see the specific comparison nodes, like the I = 0 and the I = 1? The answer is, who knows? At a certain point, we will. At a certain point, walk is going to take all of the children that were basically taken by the previous answer, so he's going to roll through them, and at a certain point, finally, we will find the children of the actual node that we are going in. So we are at the 7th node, and to actually be able to find our I = 0, check, we are going to wait until the 16th node. So the 16th node is going to be this one. I hope that the 17th is the I = 1, and I hope that this gave you an idea of, okay, what happens when I basically invoke walk. This is, I mean, it's super cool. Like everything is going to be caught at a certain point. So if you have just weird code that you want to track, this is going to be tracked. A list comprehension nested inside a list comprehension, AST can take them both. But it will do it in its time, its own time, in an unordered way, and so on and so forth. Now I just hope that this thing basically just disappears. Okay, now. Okay. So at this point, let's say that we are human beings. I am personally a human being, and I like to read code one line at a time personally. Also, this is non-standard, but sometimes maybe I'm interested in saying, okay, what if I just want to take a look at all the assignments that a small function has? I make all of the hypotheses about my code. I'm just interested in taking a look at all the assignments one by one, iterate through them, and just taking a look at the statements. Well, you can do this. You can actually just play with this kind of stuff. You receive your own node and do something that in a recursive manner just tries to then keep iterating the bodies, which is basically just the list of the children, and just, okay, just give me all of the statements, seal them one at a time, and so on and so forth. Don't try this at home. This is just some very stupid thing that I wrote because I needed it at a certain point. And unfortunately, one does not simply iterate bodies. There is more stuff. A try-catch statement may have some handlers, which are all the exceptions, and they are other list of the sub-nodes of the lines that are hidden inside the excepts of a try-catch. Everything has an or else, and the try-catch has a final body. So up to my knowledge, you may need something that basically just programmatically takes all of these attributes and just check for all of them if they actually exist. Super coolest way that I found to express this kind of weird thing that I needed for myself is to just unroll the AST statements. So walk through everything. Fortunately, I kind of like discover this kind of stuff. AST has these kind of like overclasses, which are AST.stmt. It's statement for him. And basically, if something is a statement, it needs that it is a line. So this is not some nested call that you may have somewhere. This allows you to basically just take them, sort them from their line number. The statements have a line number, and so you can basically then just unroll your own code one line at a time. This is super non-standard. This is done by me, so don't take this as something like given by Python or something. So it may be full of bugs. But this is just to say, okay, if I want to read the code one line at a time, I hope that there is some standard way. I just didn't find it in the documentation, and I had to, well, code it for myself. Coming back to like super standard stuff, not visitor and non-transformer are like the mostly type used, are something that is super used, something super supportive that the library will give to you. And this is basically just an abstract class. You can play with that. I don't know if it is specifically abstract or not, but at the end of the day, it's an abstract class. You need to redefine a lot of methods in which you will have to write the name of the node. That's why the nodes are useful, because when you are writing the names of the nodes are useful, because every time you're just trying to write your own visitor, your own transformer, you need to specify him, okay, this is what you do every time you encounter a function def. In this case, what I decided to write something that just prints the node name, and if it has a return, it prints the ID. If returns is not known. Also, if something has some substatements, so for example, a function then implements a function inside there, decorators or whatever, you need to invoke self-generic visit on the node. This will allow the node visitor to be called in the same way also on the children of this node. So if in case they are nested function definition inside there. Just write this to let the some nodes get visited. You basically use this by defining this node, you define this class, you define its methods, then you just construct it and you tell him like, okay, visit my tree. It's easy at the end of the day. This part was quite easy. Transformers, I actually have to say I almost never ever use them in my life. Every time I need to generate code for myself, I mostly like just read the stuff using AST and then I do my own like code writing. But transformers are super cool. In fact, you can actually manipulate your own abstract syntax tree, do stuff on it, and then you can basically in the end say unparse and just regenerate code. And you basically get a way to modify your own Python code without modifying the string. You can just tell him, okay, this is the abstract syntax tree modified for me. What the node transformer is going to do is it works in the same way as the node visitor. You define with a function a behavior that you want for a specific type of node, in this case list comprehensions. And you can say, okay, instead of returning the original list comprehensions, return the original node modified, whatever, and so on and so forth. In this case, we are just taking a list comprehension. Instead of the list comprehension, we return a set comprehension with an element and with the same attributes, basically, in the constructor. Pay attention. We need to write self-generic visit node if we want also this thing to be done also to its children. So let's say that we have nested list comprehensions. If we want them to become nested set comprehensions, just use generic visit. Why are we interested in doing this? I didn't know, but it could be fun to do this on a code base. Don't do it at work. I never told you to do this. And most important thing, just, okay, then you have to reassign the tree. But don't do this, don't do this. I never told you, I never gave you such ideas. There are other helpers at the end of the day inside the AST that are useful. They may not be useful to traverse the tree, but they are super helpful, super funny. You can get your original source code for a node. So if you still have your own source code, you can get the original source code. You give it the node, it has an end line, a line number, and you have it. You can get the docstring of a node. This works for function definitions, class definition, whatever. You can get the docstring like easily. You don't have to write your own stuff. You can directly iterate over some child, or its direct descendants over the children of a node, without usually walk, which is going to basically just dump and just unroll everything. You can use dump to print it, and unparse. This regenerates the code given an AST. So if you just modified the tree, you substituted all of your list comprehensions of your colleague. I mean, don't do that, but if you want to do it, and you can basically unparse it and regenerate its code, completely destroyed. So I hope that you're not bored. We may all be. Demo time. Are we ready? Yes. Let's hope that I am. Let's hope that I am. I'm afraid. Let's hope. So, let's see. I prepared something that was pretty stupid, and in which I deleted almost everything. My idea was, let's take a repository, Pydantic. Can you also, I hope that at this point, okay, do I need to zoom more the character size? Is it okay? Okay, we're just going to take, AST, a lot of stuff. we take a Pydantic. I cloned Pydantic, so but it could be whatever code base. But I chose Pydantic. It was famous. Then I wrote some code to iterate the files, but this is not interesting. I just want to iterate through all the files. For every file, I just want to parse its to parse the syntax tree, give it an input to a node visitor, that for which we will have to implement methods. I just give him all the time the path and the code so that, well, easier to print stuff. Then this thing will just, let's hope that I get to define some data frames and do something fun. But my ideas are basically, okay, let's build a data frame with some functions data, because after all, there is also PyData. So let's build some data. So let's scrape some data out of Pydantic. Then I would have liked to say something like, okay, where are all the imports? Just print all the imports, something stupid. Then something stupid with the classes. If we get, I would be curious to see if, are you actually curious to know if Pydantic has data classes? Like, has Pydantic a data class? Is Pydantic using actually a data class? Pydantic gave us a super alternative to data classes. But is Pydantic internally uses data classes? Let's try to answer this. I already have the answer, but I will try to repeat it. And also something cool if we get to check if there are callables or whatever. But let's start. So what do I need to do? I need to redefine all of these visits, but these visits, and so that I make it, just forgive me in advance for all the bugs that I'm going to write. But let's say that we are interested in taking a look at the function defs. Okay, this basically prepares everything. And also the code is already written, so there is already the solution. So if I'm not able to write all the code, we can always resort to this. But okay, let's say that we just want to have this thing, self.generic visit node. At this point, what I'm interested in doing is basically just storing inside a whole self-func data, a list of dictionaries, because that's the way in which I usually just use to build data frames. I would like to build a dictionary inside there. So let's say that to func data, I'm going to append some kind of dictionary with, for example, I don't know, the number of lines. This could be something that we are interested in. And I try to design all of these things so that we actually get to play with the abstract syntax tree. So at this point, finally we can get to play with the abstract syntax tree, and I love Visual Studio Code. We see that there are all of the attributes. The function has a body and its decorator list. There are some decorators possibly for this function. You can find all of this stupid stuff inside directly the abstract syntax tree. Everything is already parsed, so we get to play with this. Let's take, for example, the number of lines. We take the line number of the node, and we subtract to it its end line number, or maybe the opposite. Is it the opposite or not? So, okay, let's say end minus the line number. You can be interested in getting like the function name, node.name. Probably I forgot a comma, so Visual Studio Code is not helping me anymore. No, there is a name. Okay, it's the number of chars. At the end of the day, something I wanted to print a scatter plot. This was a PyData after all. So let's take the number of chars, which are, I need to say ast.get source segment. Get source segment. I need to provide, to get the source segment, the set, the code. But for some weird way, we can assume that every time inside our full class, the code is going to be reset to the code of the specific file. This thing will run the whole file. Get the source segment and then the node. Guess that this is basically everything that we are interested at this point. Let's see if this runs. Let's hope. I will keep the fingers crossed. To do. Let's see if this works. Okay. I completely forgot to write like every label around the plot, but this is a scatter plot which gives you like on the x-axis the number of lines for all the functions and the number of characters on the y-axis. Something that was a question that I wanted to say was, are they correlated? Yes, they are correlated. They look like to be, yes, in a function we can presume that inside Pydantic the number of lines of a function is linearly correlated with the number of characters inside the function. Something stupid that you can have, but it's pretty easy. Okay, this is like the distribution of the number of code lines. This time I wanted to write a title, thanks myself yesterday night, and we have the count of the lines. And, no, the number of code lines, the number of code lines, and the count of functions. Most all of the functions are very, very short, and yeah, this is a sign like Uncle Bob would be kind of proud of Pydantic. Never write more than 6 lines in a function. I do it all the time. And at this point, okay, we are done. Cool thing that I hope everybody like wants the answer. Like, does Pydantic have data classes? 10 minutes, okay. Does Pydantic actually have data classes? Like, please raise a hand if you're interested in knowing this. I was dying yesterday night. Like, let's hope that I get to do this. Okay.
What's the answer?
Let's try if we can get it. Now you have to wait. If you know the score, no, it's going to be like no. There is already the working version. So this is. So if I fail, we'll always have a solution. But what we need to do is visit all the class definition. I get that like a data class is a decorator that you need to use on a class. So we are looking for classes. And here we are. Am I interested in all of the subchildren of a class, let's say nested classes that are declared? I don't know sincerely, but I will say yes. Let's invoke this thing to be generic visit. And also trying to reason, like something that I wanted to do. At this point, we have an option, I would say. Once we are inside visit class def, we are owning the class. Like we have it. We have its own we have the parsed class, and we can do 2 things. We will do 2 things once I would like to, because I would like to take a look at all the callable classes. But we don't need to take a look at the body or to walk the class to get the decorators. Actually, there is a decorators list. If we're taking a look at it before, bang, we have a decorator list. It's so easy. We don't need to write our regex with the writing. The decorator list. Now, at this point, if we want to check whether or not there is one, I think that we basically need to do something, which is an if. And let's say that we are just going to take a look at like data class directly imported as a, let's say that they wrote something like from data classes import a data class. Because it could have happened that they wrote something like data classes dot data class because they just imported data classes. I will be just, no, it's pretty simple stuff. Is data class inside? I will say a set. I love sets. Like, let's say something like in, what do I have to say? In decorator. I would just need a set comprehension with all the IDs of the decorator, in this case, for decorator in decorators. I like an S to be written here. Decorators, and it's pretty useful to check if the decorator has actually an attribute ID. It may be that it is actually a function, so it may not have an attribute ID. In case we have it, in case we have this, let's say that we want to print a formatted string. I just let them more. With, what can we say? Well, the name of the class, let's say. I'm just improvising at this point, like, yeah, so if you have like any suggestion, it's always welcome, but I would say the name of the class, its line number, so that then we can check it, and its path. Hopefully there are not going to be bugs, and at a certain point, if there is something, we are going to get something like the node, self.path. Let's hope that this works. I thank you all for having followed me up to inside this whole writing stuff. Let's run this. Okay, yeah, there are some. Okay, now let's just, I don't want the figures. There are the ones from before, yeah, because there is the solution from, okay, yeah, I just tried it before. How many of you have actually already saw the solution? I hope, yeah, somebody did. But we have some data classes, Are we interested in checking them where they are? Let's say yes, like I just want to prove it to myself, basically, at this point. Let's open a new window. Hope that nothing like super weird is taken, like from my recent. I have Pydantic. Are we taking a look at them? Let's just go there and check it. Pydantic descriptor proxy, line number 163 of Pydantic internal decorators. Pydantic internal decorators. I hope you can see this. I should just improve this also a little bit. And it's line 163. Oh no, there are already some. Which I don't know why I didn't catch them. But then line 163, inside decorators, There is a data class Pydantic descriptor proxy. We caught one. Don't ask me why it didn't catch the other ones. I'm just coding live. Repos Pydantic. This is some weird bad moment. But as I said, bugs were going to happen in this demo. But as you can see, it was actually capable to catch them all, and you could actually express them in a pretty easy way. You can unroll all of the classes inside a file, inside all the files, and express everything in a pretty doable way.
What would happen if they use data classes without the decorator syntax?
Without the decorator syntax?
Yeah, using other syntax that still adds the data class property to a class without using the proper decorator.
I guess this is not code. It's the same thing for the imports at this point, because basically, well, you can import stuff with import lib. You are free to, I mean, I think that I did it sometimes. I was importing stuff with import lib. Okay, this is not code. You need to check for all of the calls of a function. You need to know what you're interested in.
Yeah, but maybe some fuzzy programmer missed it do it.
Yes, they can do. Yes. Okay. Yeah. Thank you very much for saying this. You raise a point. Like every time you are writing stuff with AST, aside from like taking a look at all of these bugs and stuff, you have to be very careful at what you want and the fact that they need different ways to express what you're actually looking for. For example, the imports, they may be done in a different way. The data class may be done in a very different way. There are pretty like, how to say, weird things that can be done in Python. So one last thing, if we have some time, I would like to take a look at the imports, just to take a look at another node. Do we have like, how much time still? 5 minutes, like, okay, we make it in time. Let's say that we want to take a look at only one type of imports. For example, let's just say that I want to visit all of the imports. Just imports, otherwise it will not make it in time. And I just want to, of course, do all of the self-generic visit of node, and in case I don't think it is going to be useful. And then I'm going to just print, let's say, something that I was interested in. Are there like scattered imports? If the node line number is bigger than 100, this is something that you can actually do. Just print me like the same stuff that you were doing before, like for the class. Just print me not the node name in this case, but its path, its file name. In this case, I'm only interested in the source segment. So ast.get source segment of the node. I need to pass it the code and the self and the node in this case. So if I get to run this, I should be taking a look at all of the times in which something is imported, and we're just taking a look at all of the imports, not even like the import from. We're just taking a look at all of the imports, and there are some imports that are at line like 1000. Sometimes Pydantic looks to be imported like at line 1355 import JSON. It needs like, yeah, like you can. I already saw the guy one time talking, like great guy. If he decided that the JSON needed to be imported, or some contributor, it's imported. So at this point, we have just some 5 minutes. And I hope that you saw like how easy it is to write stuff quickly with the AST. Like you have like already some support functions, walk, not visitors and stuff. You can easily try to write your own stuff. You just need somehow to know the nodes. But it's actually pretty easy to just write something that is kind of like useful. So of course there are worlds beyond, so I just showcased like a little bit of the things that you are actually capable of doing with the library. Let's say you can always use also compile function to obtain your bytecode, and there is an ecosystem behind the AST. So there is a great talk for which I provided the link that basically describes tools that rely on AST to do pretty crazy stuff. There is basically kind of like an XPath querying language based on AST, so that you can say, okay, invoke me like just in a string, tell me like all the class definitions that are callable, and so on. And there is an Amazon Python AST. So finally, personal opinions after like 2 years that I use this library. I will be honest with you in the end, it's rarely useful. Like I rarely use this at work. I have a personal project in which I use it heavily, but it is rarely useful. When you use it, bang, a game changer. Like I love it. Like you can do a lot of stuff in such short amount of time. It's great. I also don't use it for so long. I always use it like for short periods of time, because this library in short periods of time allows me to do like a lot of stuff. A personal hint, so if you think that it can be useful to you, try it. It's easier, and you can just say import ast. So when every time you are like, oh my god, I need to write a regular expression for Python, just import ast. It could be a pretty good solution. Then finally, okay, some links to the resources, like there are the official docs, the official documentation. Green Tree Snakes is the unofficial documentation for AST, so you can basically just be like interested in reading this is more like how to use it. The PsychoPG article was super useful. I was on Python AST. And the memes at the beginning with a regular expression, is the AI learning from me, am I learning from the AI, is programmers are also human, comedian from YouTube. And at this point, well, thank you for the attention.
Thank you very much, Domenico.
Mi levo dal...
No, the
questions.
time.
Oh, okay. Oh, no, okay. I was going to... No, no, okay. Oh, no, I'm sorry. Okay.
Questions? Someone. There you go.
Have you ever tried it with the eval statements? So the eval statements. So you sometimes do eval and then a string inside the Python code. And maybe the string is parameterized by another parameter. I saw it somewhere in some open sources packages. So you have eval, in parentheses, the string that is import, AST, and then whatever. Have you ever tried AST on this kind of objects and how it reacts in case?
Never.
It's a strange, eval is low use, and for me it's a lucky. But anyway, it was just for now.
I never used it. As I said, there are words beyond. I mostly use it in situations where I have like a lot of code, I need to parse it and get information. I mostly use it to retrieve data.
Okay.
So I kind of like used it for this. But just please like tell us, because like this is, I mean, also I read somewhere that there was people who was using eval, but I was like, yeah, I don't do this stuff, and I never needed it. But just thank you for having pointed this out.
Okay.
I remember actually having used eval once many years ago, and they told me, they posted me a link that was written, the name of the article was "Evil is Evil." and with all explanation why you shouldn't use evil and instead use, the point is evil uses a string.
Yeah.
You're not actually getting the structure of the code.
Sure.
You're just putting the code into a string and then feeding evil with the whole string.
Yes.
But you're not getting, you're losing all information about the structure of the code inside of it.
Sure. And sometimes they use also it for naming new variables, and that's really crazy. Yeah. So I totally agree with you.
Insane. In this case, you should rather, I mean, if you really want to do it, name a new variable like that, instead use the locals dictionary or the globals dictionary.
I think you can use eval in the decorator. The decorator, you can take the ast, write, and make eval for at runtime. I think it's possible. With the decorator, you can take at runtime the ast of the function, rewrite the ast, convert in string, and make eval on the ast write. I think it's possible.
Don't know, but probably.
I guess he can. I already talked with him. He's like he's super. I guess he's way more expert than me on AST. Yeah, I firmly trust him. Yeah.
Python, I think is bytecode.
Yes, because you can get a bytecode, and AST can actually generate the bytecode for you. Yes. As I was basically saying at the beginning, and I put this is just my personal, and I mostly used it for reading stuff. But as I was saying in some slides ago, worlds beyond. So if you want to play with this, you open like a door, and crazy stuff can happen. Crazy stuff.
Okay, probably it's a silly question, but I was thinking if AST is can be applied also to other programming language. I mean, usable to learn more from a C library, or just to parse all the files and see all the classes, etc.?
Okay. In my limited experience, I'm talking just for my limited experience, these AST, the abstract syntax tree is not an invention of Python. It exists for several languages. It's just a theoretical programming concept. What this library does is basically it exposes you the internal stuff, the internal C code of Python, like all of the nodes that I mentioned. You can find them inside the CPython. So this is like CPython. You go inside CPython, you go inside its ASDL, H files, inside its C files. You will find all of these nodes. So this library that I exposed to you, it targets Python. It expects Python code, and it basically exposes you, and I think that it just exposes you an internal functionality of Python. I mean, Python needs the AST to work. Otherwise, it doesn't work. But I guess that there are abstract syntax tree libraries for many other languages. So if you are just interested in some other language, I guess that you need to check the reference AST for the language if it has. Python has a standard AST, so just use it, and in case just learn Python, just use Python. That's the kind of suggestion I have to you. Just use Python.
Or regex.
They are good. They are good.
I'd say, having used other programming languages and having seen abstract syntax trees in other programming language. Having seen other programming languages and having used other programming languages, I have to say that the abstract syntax tree of Python, yeah, it is a powerful tool. I mean, that you can use a library to just import code and analyze it as a data structure. Though I think other programming languages have much more advanced metaprogramming capabilities. I think it started all with Lisp back in the 70s, which is basically a programming language that codes itself as its own data structure. I mean, in Lisp, the programming language is the data structure it has in native. And I think that Ruby and Julia, the recent Ruby programming language, and Julia especially, which was a programming language that was started a few years ago, has a really nice metaprogramming capability in that you don't even need to import a module as separate like ast in Python. The programming language itself can represent itself as a data structure. Mm-hmm. So, and that's really nice because you can recompile it and do some runtime optimizations stuff. But I think the best idea ever that I've seen is Wolfram Mathematica. I don't know if you have ever...
No, just MATLAB, all of this. No, I just went directly to... I passed through
I don't know if anyone is aware of Wolfram Mathematica. I mean, the whole programming language of Wolfram Mathematica is an abstract syntax tree that defines transformation rules upon itself. So when you're actually inputting an expression, it gets interpreted as a programming as an abstract syntax tree and looks up the transformation rule for that for that case with a pattern matching for transformation rules set for abstract syntax trees. So maybe the question is, what are your opinion of the comparison? Maybe have you ever had the chance to compare the abstract syntax tree of Python with other programming languages?
I will be quite honest. I mainly use the AST with Python. Rarely I need to do such stuff. My other experiences, well, professionally I also coded in Go and C++, and then, well, they have you can do doing metaprogramming in Go is okay, but you can do it also in C++. It's quite hard, but you can do it.
Well, actually, with C-Lang right now, libVLLM is I mean, the low-level virtual machine. I mean, it's kind of, I mean, still hard, but you can kind of do it right now.
I will kind of give a personal idea that I had on the topic while I was working on it. One of my ideas is that Python. The way in which I discovered the whole AST for Python is that basically I needed to. Python was my raw data at a certain point, and there is I think that there is a lot of Python, and I also at work, basically at work I receive waves of Python. So this is one of my tasks is receiving waves of Python, and basically there is the need for using AST just as a parser. Honestly, just with my limited experience, I mostly write Python, and when I write it, I do not miss the whole meta-programming capabilities because it's a polymorphic language. Like at the end of the day, everything is a pointer to a class. So I don't need that much to transform it or to do weird meta-programming stuff when I'm in Python. Already the language allows me to do like crazy stuff, like just change the variable at runtime. For a C++ developer was already boom, and there are already a lot of stuff that needs to be done. So inside of meta-programming capabilities, I sincerely I'm not a guru of Python, but basically just I never felt the need for it also because it's already polymorphic. It's polymorphic, like everything is a class, and then you can, and basically everything inherits from the same object. And that is like something that in Python is a superpower. You cannot do that in C++. You have integers, you have bytes. And that's basically like why I just rolled with AST in Python, because I had like lots and lots of Python code. So that's just a personal use case that I had. Just use it as a way to parse the stuff. And I honestly never ever used the AST libraries with other languages.
Yeah,
honestly.
for example, another use case for it. Are we running out of time?
They are looking for speakers. They are looking for speakers. They are actively looking for speakers.
We're gonna have a lovely aperitivo afterwards and dinner as well, so you're more than welcome to continue the combo. Sorry for the
No.
I need to just detach myself from this.
I will give this back to you.
Thank you very much. Il dubbio è se mi si sente o se devo girarlo dall'altra. Ok. This is up and running. Audio is good? Audio is good?
Let's check.
Yeah? Thumbs up? Okay. So, I'm sorry there will be no code here. This talk is about the EU AI Act, also known as EU Regulation 2024-1689. The upcoming, no longer upcoming, the current live Artificial Intelligence Act is a European regulation. It will make our lives meaningfully harder. I'm Paolo Nicoli, I'm a specialist at Accenture, and I am interested in cybersecurity, compliance, etc. And I stumbled upon this piece of work during one of my projects, and I got interested, and now I will inflict it upon you. So, a couple of disclaimers. I'm not a lawyer, so this deck will not save you. Contact legal, I will not be held responsible. Don't at me. Another thing, I'm not an economist, so we will not explore any socio-economical impact or effects of the AI Act on the European market, etc. If you must at me, let's do it offline. So, without further ado, this is our menu. I'll start by giving you a brief context, then some definitions, because lawyers love definitions. Then we'll deep dive into the different risk tiers, because, spoiler, this regulation is based on risk tiers. And then we'll see just the timeline, where are we now, and a couple of topics I did not mention to cover in this deck. So, let's start with the context. This is the first regulation that targets AI. It automatically applies to the whole European market because it is a regulation, not a directive, so it will happen as is. Also, we will see that almost anything can be in scope because it has a very wide definition of what it means by artificial intelligence. As I said before, it features a risk-based classification for your use cases with stricter requirements the higher the risk. There are role-based responsibilities for different actors in the value chain. There are specific provisions for general-purpose AI models, also known as foundation model, generative AI, you know the stuff. Lastly, some silver lining, there are some limitations and exceptions that put some use cases outside of the regulation, like research, personal use, national security. Most important, it is already enforced. It has passed all through the legal ether in the European Union and is being integrated in the Italian laws. On the 20th of March, the Italian Senate approved the DDL 1145/24 and is now under review by the chamber. So it's coming. On to the definitions. First one, this is the most important. What is an AA system? An AA system is a machine-based system that is designed to operate at varying levels of autonomy and that may exhibit adaptiveness after deployment, and that, for explicit or implicit objectives, infers from the input it receives how to generate outputs, such as predictions, content, recommendation, decisions, yada, yada, yada. As you can see, almost anything in IT can be in scope. Any AI model, any architecture, supervised, unsupervised, reinforcement, whatever. Hard-coded rule, expert systems, those are in too. Any functional procedure. There is an input, there is an output, it's machine-based, you are in. Why? To future-proof against the evolving technology. So the regulator put it a wide definition, and now we are stuck with it. Quick note, the models themselves are not AI systems. AI systems when they are integrated with interfaces, output, etc. So it's not the model per se, it's the AI system, the use case. Also, anything in scope if its output is used in the European Union. So regardless where they are deployed, served from, whatever, they are in scope, just like GDPR before it, extraterritoriality all the way. Lastly, as I said before, AI systems are subject to risk classification levels with increasing burdens the higher the risk. Why? Because they focus on protecting the rights and health and safety of European citizens. There is an asterisk because it's the intended use of the system, which is in scope, also foreseeable misuses, because you cannot just put a fig leaf and say, yeah, this is the strict use case and it will be obviously abused. You will be in scope anyway. Throughout the slides, there are references. The slides will be available at the end of the presentation. Also, please, the questions at the end, otherwise we will not finish in time. Other important definition, general purpose AI. General purpose AI is an AI model that displays significant generality and is capable of completely performing a wide range of distinct tasks regardless of the way the model is placed in the market, and that can be integrated to a variety of downstream systems and applications. What's this? Generative AI. You know it, you've seen it before, it's that stuff. General purpose AI models are not systems as before. They need to be integrated and then they become general purpose AI systems. There is a specific designation for general purpose AI. It's systemic risk. What does it mean? If a model is deemed so big that it could potentially pose a significant risk to the citizen of the European Union, it will be required to face stronger disclosure obligations and requirements and also perform risk assessment and stuff. We'll see it later. What are the two conditions? A training compute budget of above 10 to the 25 flops, or floating point operations, or a decision exposed by the EU Commission based on current state of the art, etc. This is a short list of what is expected to be classified as systemic risk. Why do I say expected to be? Because there will be a list available by the European Commission. It's not ready yet, but those are the main models which are expected to be on that list, because be it by disclosure or by clever analysis of the published papers, they are probably above the 10 to the 25 training budgets. Okay, risk tiers. As I said, there are different risk tiers. These are the main three. The first one is easy, unacceptable. That is prohibited. You cannot do that kind of AI systems. No way, no how. Second tier, high risk, heavy regulatory burden. This is probably the most important class because the high risk, the unacceptable risk, thankfully, are limited. High risk instead is quite open, and there are many different use cases that fall within that category. Last one is low or minimal risk. No obligation, just a voluntary code of conduct. Orthogonal to that, there is the general purpose models classification, as we've seen before, standard models and systemic risk. Lastly, there is a transparency requirements. To put it shortly, if you're interacting with a real person, you have to disclose your AI system. You cannot spoof yourself and say, no, yeah, I'm Karen from marketing. No, you are an AI system, you have to disclose it and tell your users. The asterisk on the general purpose models means that there are less burdens if you're publishing as an open source model, so open weights, open architecture. How they interact, as I said before, there are different obligations, but they are modular. They can combine, so a system can face both the risk tier obligations and the general purpose AI system obligations. You may be subject to sanction from both. Here is just an outline. I will not go through them, but as you can see, it's a combination. You can have both the tiers and the general purpose stuff. Let's see the roles. The main roles, through the roles, the obligations are defined. So if you fall in one category, you will have some obligation. If you fall in another, you will have others. The main burden resides on the provider. The provider is anyone who develops an AI system on general purpose AI model, and that's a model developed, so you cannot subcontract and wash your hands, and places them on the market under its own name or trademark. So if you put your name on it, you're stuck with it. The other important role is the deployer. So is anyone using an AI system under its own authority. So you pull something off the shelf and integrate it in your application, then you are a deployer. You did not train the model, you did not build it from scratch yourself. That was the provider. You're just a deployer, but you have the users. The other two roles come into play if the provider is outside the European Union or you have a longer value chain. So if the provider is outside, you need to have an importer who brings the model or the system in the European Union. And if the chain is longer and there is someone who is not the provider, not the importer, then is probably a distributor. Anyone here means legal person, public authority, agency, anyone. That is a legal entity, let's say. There are promotion rules. So if any player in the supply chains does one of these three things, they get promoted to provider. So they get the higher burden. So be careful. What are those things? If you put your name or trademark on a high-risk system already placed on the market, regardless of any contractual arrangement, so you cannot split it contractually. I put my trademark, but you get the burden. No way. So trademark, it's one flag. You make substantial modification to a high-risk system. So you pick a high-risk system, you change it, you are a provider now. So in a way that it remains a high-risk system. So if you change it and make it dumber or easier or less problematic, it's not such big a risk. The last one, if you change the intended purpose. There is a system with an intended purpose, you change the purpose, now you're stuck as a provider of a different AI system. Scope limitation, yes. So these are the silver lining where you can avoid being in the scope of the AI Act. As I said before, personal use. Deployers or network person who use an AI system for personal, non-professional activity. You do it on your PC, in your bedroom, no one to see, no one to be harmed, you're okay. Research and development. This is a nice one. AI system or models developed or put into service only for scientific and research and development. So hopefully there will be no impact, but I'm not an economist, so I will not go there. Lastly, I don't know if there is anyone from Leonardo in the audience, national security does not apply. So military defense, national security purposes outside of the scope of the regulation. We are through the definition, okay. Now let's move on to the risk tiers. There are the three risk plus the transparency, and Here we go with the prohibited use cases. This is the list of stuff you cannot do. You cannot currently do them because we are already through that gate in the implementation timeline. This is already into force. Don't do it. Let's see them with a bit of example so we can understand them better. Subliminal manipulation. What does it mean? Let's say you're placing an emotion detection capability in a smart TV to advertise specific products when the public is most vulnerable. Like Leo DiCaprio just drowned after Titanic, let's sell life insurances. Not a good idea. Personal vulnerability exploitation. You want to detect if retail chain customers are recovering alcoholics and sell them discounted drinks. Not so nice, don't do them, please. Social scoring, like Black Mirror, barring individuals from public grants based on social score computed from other stuff like parking fines. Prohibited. Criminal profiling, well, terrorist profiling based on individual data, that's quite self-explanatory. That one is nice. Scraped facial recognition database. Who amongst you know about Clearview AI? Ever heard of it? Clearview AI was a company who has also been fined by the Italian authorities, who had the genius business model of scraping social media and the whole internet, collecting faces and images, and creating a database of facial recognition images. So it sold it to the law enforcement agency in the US with the offering, you give us a photo, we tell you who it is. That is specifically prohibited now. So there is also a link to the news. They got fined by almost anyone, but that was a use case that is being singled out. Emotion detection, we will see it later also in the high risk. Here is specifically in workplace and education. So assistant to detecting call center employees get angry during calls, that is in the workplace, it's prohibited. Also during education, training, student, etc. The other, all the other emotion detection stuff will be high risk, spoiler. Biometric categorization. Biometric is a delicate topic in this regulation because it may fall under prohibited or under high risk, depending on some technicalities. Specifically, what are the features, what are the target of your model? For example, a system to classify sexual orientation based on photographs, for instance, uses biometric features, the photographs, to classify a protected target, protected in the data GDPR meaning, like sexual orientation, religion, race, those spicy topics, those are off limits. Last is real-time biometric identification for law enforcement purposes. Does not apply to most of us, but it's prohibited, like street surveillance to detect littering. But there are some allowances, like for instance, to find a missing person or to prevent a terrorist attack or something like that. There are some caveats for the law enforcement stuff, but I did not go too much into detail on that part. What are the obligations? Don't. Just don't. What are the sanctions? 35 millions or 7% of your global turnover, whichever is highest, like with the GDPR. So, not a good idea. Let's move on to high risk. This is a bit chunky, I'm sorry. So, there are two conditions to classify a use case as high risk. The first, I will not go too much into detail, is if it's a safety component under another European Union harmonization legislation. What does it mean? Safety components or products, or products that already require some form of conformity assessment, like think radio equipment, medical devices, aviation, rails. I said it 2 times, I'm sorry. So this stuff already has compliance requirements, will be automatically high risk. The other type of use cases that are considered high risk is an explicit list called the Annex 3 to the AI Act. Let's see them, but there will be some doozies. Here they are: biometrics, emotion recognition, critical infrastructure, da da da. We'll see them with the examples so it's a bit easier to digest. Examples. Biometrics, as I said before, it's a bit delicate. If it's not a protected target, you fall into high risk. So like identify pedestrians in front of a store to spam them with direct messages. That's sensitive protected feature, facial recognition. No good. Emotion recognition, not on workplace or education, like a system to detect if customers are interested in your shop displays. That's a high risk. Critical infrastructure, that's quite clear. System to monitor like road, bridges, water mains, electrical infrastructure. That stuff, high risk automatically. Everything in education, which was not the emotion recognition before. So, system for ranking application to training institution, system to detect students cheating, system to grade students. Education, high risk. The other spicy one is employment. Any system that does job screening application, job application screening, or performance reviews, automated. That stuff, high risk automatically. Access to essential services also is a bit chunky. System to access healthcare, or patient triage, or system to score credit worthiness to get a loan. System for assessing the price of an insurance. All that stuff will be high risk. The last four, I will not go into details because I don't think will be relevant for us, but law enforcement, migration, asylum and border control, justice and democratic process also will be considered high risk. Exception and gotchas. As before, there are some exceptions to put your use case outside of the regulation, and some gotchas to put you back in. So, how can you avoid high-risk classification? You're doing a narrow procedural task, like an OCR or a document classifier. It's sufficiently narrow, there is no risk. You're improving downstream from a human task, like a marketing blurb was already written by some marketing analyst or something, and you're just changing the tone of voice of the copy. It's downstream from a human, you're good. You are detecting a decision-making pattern. This is a bit tricky if you think about education, but you are not grading the papers. You are checking if your grading pattern is skewed by bias or something. That is not considered high risk because it's a meta-analysis on the topic. Last one is complementary to the second, preparatory task upstream from a human, like document translation. There will be a human after who will check, so the risk is limited. However, if your system performs profiling of a natural person, you're automatically high risk. What's profiling? Another definition for you. I'm sorry. Profiling is any form of automated processing of personal data, consisting of the use of personal data to evaluate certain personal aspects relating to a natural person, in particular to analyze or predict aspects concerning that natural person's performance at work, economic situation, health, personal preference, interests, reliability, behavior, location or movement. So anything concerning a person. If you're handling personal data, there's a good chance you will be high risk. This definition is imported from the other three European laws concerning data protections, the GDPR, the LED, and the EU DPI. They use the same definition verbatim. So they don't want you to do it substantially. So this is a big gotcha to get back into high risk if you thought you were gonna get away with it. The obligations. So first we will see the provider obligation, and then we will be seeing another slide just like this one, specifically for the system requirements for the AI system. So what are the obligations of a provider of a high-risk system? First, respect the system requirements. We'll see them later, it's another slide. Place a quality management system. So it's a complex of policy, procedures, technical specification that ensure that your system is compliant. Document and logs keeping. Keep all compliance documents for 10 years and logs for at least 6 months. Take corrective actions and disclose. So if there is a risky event and you are aware of it, you need to fix the issue and notify relevant parties, the authorities and the downstream value chain. You need to cooperate with competent authorities, so provide documentation, proof of compliance when required. Nominate an authorized representative if you're outside of the EU. If you're a company in US or China, etc., and you release a system in the European Union, you need to nominate an authorized representative. You need to conduct a fundamental rights impact assessment. So, sorry, I highlighted some blocks because those are the most burdensome for the provider and will require most work. So, what's a fundamental rights impact assessment? You need to categorize your intended audience into groups likely to be affected by the system, and then assess and mitigate the risks for each group individually. So you need to practice some intersectionality, check if each category has a specific risk and mitigate them. It's a big undertaking. Lastly, high-risk systems need to be registered in a centralized European database, which will be handled by the European Commission, etc. Okay, so we have seen the provider obligations. Let's double click on system requirements. Another slide, I'm sorry. So, what are the system requirements? What does your system needs to have? A risk management system. It's a process to identify, address, and monitor risks by your systems to health, safety, and rights of your users. You need data and data governance. So, evaluate and correct data for bias, document all processing choices, and use representative datasets. You cannot get away just by, I'll use synthetic data, it's all clean. No, you need to address bias and mitigate it. Technical documentation to be written before release and demonstrating compliance. There will be model cards templates. There is a list of stuff that must be in the model card. We can check it out later if we want. Record keeping. As before, if the provider needs to keep logs, you need to provide the logs. So your system must allow for a lifetime logs, tag risky events, and if your system provides a biometric match function, so you are like performing face recognition for whatever reason, you need to link the biometric record you matched and why in the logs. You need to be transparent to the deployer, so the documentation must be clear, or there must be instruction and clearly identified the failure modes, metrics, minimum hardware, etc. Almost true. There needs to be human oversight. So you need to allow for explainability of the decision of the model, clear usage wording for risky scenarios, and the possibility of a manual override if required. So if there is a risky situation, there needs to be a possibility of bypassing the AI system through manual overrides. Lastly, those provisions are still being developed. The TBD is because the Commission is working on it. You need to follow technical guidelines about accuracy, robustness, and cybersecurity. So how do you measure performance? How do you ensure your system is robust, etc. Okay, what are the obligations of the other roles? The provider had to do all that stuff. The other guys, they have it easier. The deployer must follow the provider instructions, otherwise why would he write them? He or she needs to practice the human oversight part of the deployment, monitor for incidents and risky situations, and report them to the providers and authorities to mitigate them. Inform your subjects that they are under high-risk processing, and conduct another fundamental rights impact assessment, especially for essential services access use cases. If you remember the one you want to get a loan and you're predicting creditworthiness, fundamental rights impact assessment, also for the deployer. Importers and distributors have it easier. Ensure the provider follow the regulation. Do not import or distribute if they don't follow the regulation and is not compliant. Be reachable if they need to get a hold of you. And do not compromise the conformity while you are handling the product. What are the obligations? We already seen the obligation. We'll not go through them again. I'll spare you. What are the sanctions? If there are compliance issues, up to 15 millions or 3% of global turnover. For a while I was scared, but I'm at 28, so okay. For reporting issues, you are compliant, but there is an incident you do not report, fines up to 7.5 or 1% of global turnover. Again, whichever is highest because of reasons. Okay, we're through the main risk tiers. General purpose AI, low risk, and timeline. We're almost through it. General purpose AI, obligation and sanctions. What are the obligations of a general purpose artificial intelligence provider? Provide regulatory documentations. There is a huge annex, Annex 11, which lists everything you need to provide, but most importantly, training data details and energy consumptions are a bit stinky, so that's why some are a bit cautious of releasing in the EU. Provide documentation for downstream integrations, so I provide a general purpose system, it needs to be integrated, so how would a system provider do it? Those documentations. C is the other one who was a big factor, ensure copyright compliance. So you cannot violate copyright with your model. So, and training data summary, there is a template being worked on, so it will be available. As I mentioned in the beginning, there is an open source exemption. So if your model has not been classified as high risk, you can avoid A and B, the regulatory documentation and the documentation for integration, by releasing as open weight. Open weight and open arch, you can skip two of the obligations. What's the issue? If you follow systemic risk, you have more stuff to do. So you need also to provide model evaluation and conduct adversarial testing. You need to assess and mitigate systemic risk in the European Union. So again, another fundamental rights impact assessment, yada yada. Track, document, and report incidents, and ensure cybersecurity safeguards. The sanctions are the same between standard general purpose AI system and systemic risk. There's just more stuff to be not in compliance with. Up to 15 million, 3% of global turnover, whichever is highest, you know the drill. Almost through, low risk and transparency. There is the limited risk classification, which is not a real definition in the IAC, so there is not the gray box, but it's widely used in the press. And it simply means, as I said before, if you interact directly with a natural person, you need to disclose it. So inform end users, mark in machine readable form that your outputs are from general purpose AI system, if they are. And end users must be informed if the content is AI generated, like deepfakes or similar stuff. Sanctions for limited risk, as with general purpose AI, 15 millions or 3%. Low risks is green pastures. If you're not prohibited, high risk, general purpose AI, or transparency, just the voluntary code of conduct, no penalties, everything is good. Now, the timeline. We are here in April 2025. The Act is already in force since the 1st of August 2024. The prohibitions are already live, so do not do prohibited use cases. It's not a good idea. There are also literacy obligations. You'll probably see them in your internal training materials. It boils down to people who work in AI needs to know what they're doing. So what are the models, what are training data, etc. What's coming next? Code of practice will be published. So those TBD will be coming soon. So what's the template for the disclosure, how to release your data, the guidelines for the provider, yada, yada. Then August 2025, another slew of stuff will happen, especially the penalties will come into force. So also general purpose AI provisions and whatever, notified bodies, governance, confidentiality. I did not go into it, it's just governance stuff. 2nd of August 2026 is when the remainder of the AI Act starts to apply. So everything else, you need to be compliant fully, except for Article 6.1. What's that? The safety components I mentioned at the beginning. So medical devices, toys, that kind of stuff already covered by harmonization rules that will have a little bit more time to get into compliance because they're already quite busy. That will happen in 2027. Last date of importance, 2030, 2nd of August. Legacy high-risk systems, which were released before the Act, needs to be compliant by that date. And we're through with it. So, I have an appendix. How am I with time? Okay, just power through this. There is a couple of stuff not covered. Biometric data, I've already explained it mainly, the Italian law, whatever, and the draft. So, this is what I did not manage to cover. And there was a lot of stuff. The AI literacy, as I said, need to ensure expertise among staff. AI board office and scientific panels, organs created within the EU. We don't care. What's the high-risk system database? It will be a central database. There are a whole lot of stuff about it, too technical, I'll skip it. There are redress procedures. If there are infringements, there can be a complaint to Market Surveillance Authority. They have been nominated in Italy. I think we'll see them the next slide. And a subject who is subject to high-risk system decisions can ask for explanation to the deployer. So that explainability part comes into play here. Last, this is interesting. There will be regulatory sandboxes. What does it mean? There are controlled environments in which developer can test products without needing the full checklist of compliance in collaboration with the regulator. So they can say, you are not checking for that kind of risk. It would be useful to do it when you release. So it's literally a sandbox to test your model in your system before going to market to avoid hitting your face on the wall. Biometric deep dive, as I said before, the key is in the target. So if your target is protected data, prohibited use case. If your target is not just high risk, remote biometric, you're doing like biometric identification without involvement, like surveillance camera. In public spaces, no, not a good idea. Otherwise, it's high risk. What's the Italian law? Yeah, this one is important. AI system used by public administration shall be deployed on servers located in Italy. So no from outside, not even in the EU, in Italy. So the infrastructure must be in Italy. They identify the Abridged and the cybersecurity, I don't remember the acronym, as market authorities. And yeah, In healthcare usage is restricted to support, okay. This is a snippet of how the model documentation must be provided for general purpose AI. There are the links. And yeah, this is how it was sourced, the Future Live Institute, but then I changed it to the real text of the law. So this was for a first iteration of this deck. Thank you. We are through with it. That QR code points to the slides on GitHub. They are available. The links should be live. Otherwise, you can find me LinkedIn or GitHub. Questions? I'm scared.
Thank you very much. Very insightful. Very insightful. Thank you. I have a question. If you are fine-tuning a model, using a frontier model like OpenAI frontier model, if you're using in your system, if you publish the system in the market, you are considered as a provider.
I would say so, because you are changing the model and you are publishing. So
yes.
You are probably a provider.
But if you don't do that, if you keep internal for your own system, okay, let's say you are an enterprise, okay, you're using for your internal stuff, for HR or something, you are fine-tuning a model, a frontier model, okay, and you are using it just for internal purpose and not publishing in the market. It's not available to be buy from external. You still have some obligation, of course.
Yes, because your employees are European citizens.
The question is related to the data, because if I understand correctly, you need to give evidence about the data you use for training, right? But for the fine-tuning is a delta upon the frontier model that at the moment is a kind of black boxes. I don't know what they are doing for provisioning that. I mean, it's a situation that can cause some...
Well, one thing, HR, if you remember, high risk.
Yes,
so,
high risk.
Let me think. If you keep it internal, you're still having you're both a provider and a deployer, because you are deploying towards your employees. Towards your employees.
I didn't say the scope. Maybe,
that's right. Let's keep it neutral. Towards your employees. And so they are European citizens, so you will fall within the regulations. For the disclosure of fine-tuned data, I don't know what the consensus is. Keep in mind that work is underway and there are lobbying efforts by Mistral and other hopefully big European AI companies. So it's still in development. Probably in the guidelines there will be some details. I don't know if I can show you this link. Maybe. Is it live? Okay. Because there was a field on this. That copyright transparency. Sorry, can I download it on your system? Okay. Oh, just asking for before.
50 million.
Okay. Now I have no idea where it went, so I leave it to you to find it. Okay. Yeah. Yeah, if you scroll down, there should be again. If I remember correctly, yeah, those were the fields. It's a bit small, maybe I can zoom in, yeah. So, model authority, model properties, total model size, training process, okay. Specification, relevant different parameters, decision rationale. So there will need to be details provided. I don't think they will ask you to provide the whole training data because maybe technically unfeasible, but there will be some obligation on that part. Watch this space, at least not this space, but that space.
Thank you.
Okay. No, there is one.
No. Okay, bye. So first of all, thanks for delivering this thing in a fun way for something that is clearly not a fun subject at all.
It was not.
Like less in a technical sense and more in a like socio-political sense, which is clearly not your field, but still.
I'm not an economist. I said
Yeah,
it.
exactly. It seems pretty
Second
obvious
disclaimer.
that a lot of AI stuff will be pretty hard to run in Europe, and us as Europeans, we will have as Europeans a bit of trouble being able to access some of the stuff that will come out outside, as in like America. So, how do you think this is going to affect, in general, the way of life that Europeans have compared to Americans? First of all, I'm thinking like colleagues here that are working for American companies that suddenly like American companies will have trouble just sharing the same tool chains that they're using because of some regulations or something. I imagine that stuff like Claude or GPT will comply to all of this because they want to, but in general, it feels like more and more of this stuff will be accessible mostly for people outside of EU.
I think there is two things to consider. First, it's not just the EU that's doing AI regulation stuff. There are also some regulation happening in California, some in China. Did not cover them with this level of detail, but I think it's not an isolated case. There are movements because, as always, the industry jumped ahead and the regulator followed. So they are following because, like, Clearview AI was not something nice to have around. So the regulators are taking notice. There are also lots of money moving around. So yeah, there are pressures on both sides, but probably the regulators are trying to shore up against the most rampant use cases. And remember, it's a use case based, not the specific model. Mm-hmm. So if that use case is problematic in terms of citizen rights, then yeah, it will be blocked. But other stuff is not.
Sure, but like in my example, like someone Italian working for an American company, and suddenly you get that the American company is able to profile you more than what's allowed in Europe, and you are an European citizen.
No, it will not be allowed to profile you more.
Yeah, that's what I'm saying. Like, since they're Americans, they're doing that on their employees, but you are not one of them in a certain way. So you will, like, do you think that's gonna, for instance, create a divide between American companies hiring and European workers? Or the other way around as well, because
that could be a side effect, but there could be also a brain drain towards more rights-preserving markets.
Yeah, definitely.
So we'll see. I'm not an economist. Second disclaimer.
Or a lawyer.
Not a lawyer.
But in general, any system software can re-enter in this.
Potentially, the thing is, if your system is, let's say, an expert system, just some rules.
Yes, prologue. Deterministic prologue.
Yeah, then it would be kind of easy to provide the documentation required. So these are the rules. I checked. They apply all the same to both not both to all the subpopulation groups identified. Obviously, if you have a system that actively discriminates, then it could be a problem because you will be required to disclose it. But otherwise, if your system is not particularly complex, the documentation will not be too cumbersome. Yeah, there are some regulatory burdens coming. Again, it's a use case based, not a technology or a model based approach. So if your use case does not fall within the high risk stuff we've seen, it's just a voluntary code of conduct. Yeah, I'm downplaying the issue, I know. Okay, I'm sorry.
Thank you. Okay. I think that this might be our last one. There you go.
Very quick question. What about personal usage? I mean, you said that they are outside. But if I publish some code on GitHub, and another people download the software and do social scoring.
They change the intended use case, so they become the provider for that specific use case. There was the I lost the
But if I use the software on my personal smartphone, like I'm here and record the...
Well, please don't. But apart from
I
that,
could.
If it's for personal use, should not be a problem. I don't know, this probably, as with all regulation, when you come down to the fine hair splitting, it will be up to the courts. A judge will decide. So the rule of law, the regulation covers the main categories. Then there are some boundaries, some gray areas. Those will be adjudicated probably by the rule of law. I'm sorry, I don't have an answer. But as long as it's just confined to your personal use, you should be outside. Publishing on GitHub, that's a bit more of a gray area. You may fall within the general purpose AI provider stuff if you release a model on Hugging Face. But then, if you establish a perimeter of intended use case, it could be avoided somehow. But we will see.
Okay, thank you.
Again, much of this stuff is still work in progress. There are commissions and et cetera, et cetera.
Thank you.
Right. Actually, I have a quick question, but I want to ask you. Tell me yes, no. We can talk about it more at dinner.
Okay. Let me put.
I saw that like half of the high-risk usage was stuff like crime prevention, the borders, so on. How does that gel with the fact that national security is one of the excluded cases? Is there any sort of like thing that says like, oh, you can't just say that you're applying it to migrants because of national security? Because I don't see a company doing it by their own lonesome, being like, oh, what should we do for a product today? We should do like border security.
That part is again a bit delicate. There have been some pressures on the regulators on that front. I did not expand on it because it was a whole presentation on by itself, and not many of the audience would be interested. But yeah, that is a topic to watch because there could be some gray areas to keep in mind.
Sorry, I had the burning question. Okay, thank you everyone for coming.